Everyone, April 14th. All right, let's do a fast one. Deal with this first. Some root to leaf numbers. Given a root of a binary tree containing digits from 0 to 9 only, each root to leaf path in the tree represents a number. For example, okay, return the total sum of all root to leaf numbers. Test cases generate such that the answer fits a 32-bit integer. Leaf node is a node with no children, so this one will be 12 plus 13, right? And this one should be 495 plus 491 plus 40. Okay, so basically what we're gonna do is we will return whatever this return because I need to know. I probably need to do a log on this, because let's say this one returns 90. Yeah, what do we return from here? This return 5. Come here. I mean, this will have 95. This will be 91, right? I mean, technically, you can do 95 plus 91. But then because you add them 2 times, right? And then you'll pass in here. What does this one do? Okay, I can pass a list. I wonder if that's really necessary. It's like this one passing up will be a 10, right? So this will be a 10. And no, this passing is just a 0, right? 0 is 1 digit. So this one would be a 40. And because there's only 1. But this come out, if I add 95 and 91, if I add them together, I probably shouldn't add them together. So a list of numbers. So for each root, I will return a list of numbers. And at the top, I get a list, basically just a list of numbers, and I find out, okay, we can do logarithm. What would be the better way? Yeah, I think logarithm length, and then you take floor, right? Java log 10. Okay, Java has log 10. Okay, it's 2.0, so I do have to take 200 will be 2 point something, right? And then it should be, ooh, is this ceiling? It's ceiling, right? Because this is 3 digit. 2.0 is 3 digit. I mean, I can cast this. Okay, what is the cast value? Actually, I don't know. Just go math.log10, right? Math.log10. Let's say this, okay? And math.ceiling, math.log10. 3. Okay, I actually don't like it. I probably just, can I end this? End this is 2, right? Which is fine. So 100 will be 2, but if it's this, it will be 1. If it's this, it will be 0. Then I plus 1. Right, that's the number of digits I need. And then I can say math.power. So does it have math.power? Power of 10. Huh. That's actually not a bad idea. That's actually not a bad idea, because at most you get, so like if it's 0 and then times 10, so I just do, yeah, 10 all the way to 9, right? Like 9 zeros. Yeah, all the way to 9 zeros. Like we just do this. 0, 1. Yeah, we do that. We do that. Okay. All right. So with that done, I'm actually happy with this result. With that done, I think we are ready, don't we? Yeah, we're ready. We're ready. Yeah, we return a list. A list. Yeah, we have to return a list. That's okay. Maybe there are better ways, but this is the way I'm gonna do. Okay, so I need a helper. Private. We'll return a list. Right, we return a list of integer of helper. Tree node. Then we say if not node, now we have to find the root, the leaf. If node dot left is not equal to no, equal to no, and node dot right to no, we should return. Okay, let's just say list integer rest equal to new array list. All right. So leaf rest dot add dot val and return rest. Done. Okay. Otherwise, then we say list integer left if no dot left is not equal to no. Okay, then we can say for int n value of helper no dot left, right? Because I need to populate the current one. Oh, we need to do this. Int power of 10. Power of 10. 10, 2, 3, 4, 5, 6, 8, 9. Okay. All right, so we have this, Then we say int p shall equal to this v. We do int math.log10 v plus 1, right? Then we say rest.add this v plus node.val, right? Node.val times power of 10 p. Okay, so we go through that and we do the same thing. If node.write not equal to null for int v helper node.write p equal to the same thing. I can write a function for this. Get power of 10. Sounds a good one. Private int get power of 10. Give a value. Right. And then we say p shall equal to int math.log10 val plus 1 and return power of 10 p. So now we can say we list times get power of 10 v. Right, don't need this. Same thing. Say rest.add v plus node.val times get power of 10 v. So once we're done with all that, then we'll return rest. So here we'll get int rest equals 0. Okay, then for int v of helper helper root. Oh, dot left. Oh, I see. I can do that if root node is equal to null. Let's return rest. Right. So now I can do this. Then I don't need this. Right, this is not necessary. Not necessary. Not necessary. Yeah. Delete that. Delete that. And then they can all come here. Now I can say row.left. Nah. I think we just call root, right? Yeah, we just call root. This is where root is not returning anything. We just call root. We call helper on the root. Then we'll get, yeah, I think I can just do that. Right? We do helper on the root. Then we will get a list. I will get a list for both. And okay, does that include? Yeah, I think that is. We do that, and we say rest plus equal to v, and then we return rest. All right. Okay, let's give this a shot. Let's see if this is right. Oh. It's right. Index out of Which one? Index. That is interesting. What the hell? Get power of 10. I don't know what happened. What the hell happened? Ah, this is always. Okay, the first one's right. And oh, maybe it's 0. Yeah. Holy crap. Okay, so if it's a 0, it's a different scenario. And I think it's the same. So I think I just do this. How about this? Plus 0.1. You know? Yeah, because log 0 is not defined. Okay. I got 990. 990. It's pretty bonkers. Okay, let's print it out. So some value is not right. Okay, system.out.println v. Okay, let's take a look. I don't need the first one. I just need this one. What are we getting? All right, I'm getting 495. That's right. 491. That's right. Oh, this is not right. So what's log 10? Huh? Right, all right. The v shall be 0, right? So get power of 10, 0. So this is 0 comes in, but I add 0.1, so this should be 0.1. So log 10, 0. Okay, that's what we are trying to figure out. Math.log 10, 0.1. What's that? Holy crap! Holy crap! Oh Lord! All right, so 0 is a special value. Yeah, okay, let's not do this. Let's just say, actually, we're gonna do this. If val is equal to 0 as a special value, return 10. No, yes, return 10. That should be right. It's just a special value. Yeah. Okay. All right, I think it's time to submit, but before doing that, let's put some notes down. 129. It's called DFS, to build a list of numbers, right? Numbers for the current node. List of numbers with a current node as the starting digit. Okay, let's see. Is this right? Ugh. I find out that my accuracy is going down. I always have these type of issues. I don't know why. Getting really bad at doing this. Like edge cases, you're now considering that type of stuff. All right, we'll have 5, 3, 2, 7, 0. Oh, 0 and 0. Didn't consider that. Yeah, 0 and 0. Damn it. 0 and a 0. So you return a 0, right? And then a current one is a 0. Man, I was trying to do this, but do we really have to do a string? I know how I did this, right? This definitely, I think I was using string. I think because Python's definitely using string. I'm trying to, not use string for this. Yeah, value is 0, then I return a 10. So here, right, I am a 10. And so if it is 0, if this value is 0, I also need to change, right? Unless the top is a 0. Wait, what if the top is a 0? Would the top be a 0? Yeah, the top can be a 0. Damn. Okay. So if it is a 0, I return a 0, right? And then for this node, I check, okay, it's a 0. So because it's a 0, the power of 10 should be 10. So I use my value to time. So that's still a 0, okay? But that's not right, right? That's not right because I have already 2 level down. So when you get this, it's not going to be a 0. Dude, this is as ugly as they can get, man. Okay, we change idea. Instead of returning just an integer, we're returning an integer and the number of digits. Okay, we do 2 things. Okay, so yeah, we'll have to change, unfortunately. Yeah, this is not gonna work. At least in my opinion, it's not gonna work. So what we're gonna do, the helper, we're gonna change something different. Plus. That was wrong. You're not supposed to do it here. You're supposed to do it here. Alright, anyway. So we're gonna make some change here. So we don't return a list of integer. We return an int of this. Okay. And we can do int. That's fine. This is fine. And then this is going to be a new int, 2 values, no.val and 1, right? Which means current is digit is 1. And here we're gonna do slightly different. Okay, so we're gonna say, I like to call it tuple. Okay. And then what I'm gonna add is rest.add. Maybe I can still do it in 1 line. Yeah, you know what? I think I can still do it in 1 line. So this doesn't change. I should change the tuple 0. Hold on. New int tuple 0 plus no.val times, we don't have to do this, times 10 to the power of, I think I still need this one. So now we just put this outside. All right, put this outside, we don't need this. And then I will say times power of 10 tuple 1. Right, if it's 1 digit, then we do that. Even times 10, 2 digits times, yeah. Okay, so we do that, and then tuple 1 plus 1. Yeah, and then I'm gonna copy this and do exactly the same, except, dude, there's no except, it's just the same thing. All right, and then we do it here. Okay, let's try this one. Actually, no, because this is not right. This should be a tuple. All right, this is a int of this tuple And here I only care about the tuple 0. Okay. A list of tuples, right? A list of tuples with a where tuple 0 is the previous is the number formed by the children, and tuple 1 is the number of digits. Number of digits. Okay. How about this one? Let's give this a shot. I have an arrow case. Okay, let's see. Does this one work? Oh my goodness. Sorry, this is a oversight. Try it again. Okay, this seems to be right. Come on. There we go. This is right. So yeah, it was oversight. I didn't realize, right? You can't have multiple zeros, and that could be an issue. Yeah, that could be an issue. All right, I want to see what you did last time. It's pretty much, I think it's a string. Ooh, not a string. Ooh, I did BFS. Oh, top down. Ooh boy, top down. Yep, it's supposed to be top down. Supposed to be BFS. I don't know. Why did I do bottom up? Why did I do DFS? Yeah, it's a very simple BFS. Very simple. Holy crap. Exactly. You just times 10, right? You just times 10. You know, sometimes you start with the wrong one, and then it happens. Oh, DFS can also be simple. Not return current. Oh. Yeah, it's pretty bad. Yeah, it's pretty bad today. DFS. Yeah, how come you didn't? I did not think about doing it that way. This is pretty bad, because I'm accumulating at the bottom. So you're not supposed to. What you're supposed to do is you'll call some numbers, right? Yeah, you'll call some numbers, and then you'll pass whatever is the value. You'll pass your current value to your children, right? You pass your current value to your children, and your children, yeah, that's a better idea. Okay, let's implement. Let's re-implement. Yeah, this is bad. This is so bad. Way too bad. Okay, let's try it again. Let us try again. I am not doing DFS. I'm just going to do a BFS, so a better BFS. I probably have to, yeah, we have to do this. We have to private int helper again, and tree node and a val. Actually, this is going to be a previous val, right? So previous val, it's going to be int preval. And here we're just going to return helper root, and then previous val will be 0. Okay. All right. So we shall say if node is equal to null, right? Then we just return 0, no question. Otherwise, we say if node is a leaf. Actually, does it even matter if the node is a leaf? Because you can return 0 and 0, right? It's the previous value. So the previous value passing to this, right? And then I'll also times 10 add this. And I'll pass this down. And this will return. You know what? Yeah, it should be 0. It should be 0. And we can say int res shall equal to preval, right, times 10 plus node.val. And we say if node dot left is equal to null and node dot right is equal to null. If this happens, then we just return res. Otherwise, what do? Otherwise, we shall return. Do we do node helper node dot left? Yeah, we should return. We say helper node dot left this plus helper right preval. No, res. Probably don't call it res. Let's call it current val. Current. Let's do current. So this is gonna be current, and this is gonna be current, and this is going to be current. Yeah, I think that's pretty much it, dude. So much simpler, much better implementation of DFS. Yeah, was quite a shame. Didn't think about it. This is the right way to do it. Yeah, look at that. Look at this. Would you look at that? Huh? Would you look at that? So much simpler. This is the right way. This is the right way to solve this problem. Shame. Okay, so we're done with this. This is yesterday. I want to try this one again. Okay, I want to try this one again. Because there is a better way to do this, and I want to try. I mean, this is not bad, okay? This is not bad, but there's a better way. So we can call this. This is a one pass with less space. Right, well, less space. Inspired by LeetCode 15's solution in the forum. And the idea is the same, right? The idea is the same. Using sliding window, but we use a counter to keep track of the number of frequency, right? Frequency of each number, right? Each number, and if, right, of each number, if the current window has too many, right? If the current window has too many numbers to remove, we shrink it. Yeah, this is the spirit, right? This is the spirit of sliding window counter. So we can say counter, you go to counter, Okay, and then we say I equal to 0. I equal to rest equal to 0 for I for j and enumerate nums. Okay, so we always counter it and plus equal 1, right? And then we're gonna say res equal to maximum res and a counter n. And then if j minus I plus 1 minus res, right, this is the maximum, is larger than k, then counter nums I minus 1 and I plus equal 1. And at the end of return rest. Yeah, this is the right way to do. Need no type. But just about counter. Right? Semicolon. Come on, man. I haven't written Python code for a while. Get a little bit rusty. Yep, this is the right way. This is the right way. I mean, time-wise, it's fine. All right, it's fine. It's the same thing. It doesn't really matter because it's always a when. Okay, so that's that. It's a good problem. Oh, we have to unlock. Another easy one. All right, I don't want to do this. Let's leave this for tomorrow. Okay, that will be it then. Nice. I will see you guys.